Have you ever wondered how we as complex beings came into existence? It's a question that has sparked curiosity and debate for centuries. To unravel this mystery, we turn to the concept of evolution, a cornerstone in our understanding of life on Earth. It's a story of change, a tale of how life adapts and diversifies over eons. However, the topic isn't without controversy. Some advocate for creationism, pushing for its teaching in classrooms. Others challenge existing theories, arguing for an overhaul of mainstream evolutionary theory. These debates are not just about understanding our past, but also about shaping the future of biology. Yet, amidst these contentions, one theory has stood the test of time: Darwinian evolution. This theory, proposed by Charles Darwin, has profoundly shaped our understanding of life's complexity and diversity. It's a journey that starts with a single species and leads to a planet teeming with life. So let's dive into the fascinating journey of Darwinian evolution. Our story begins with a young English naturalist named Charles Darwin. In the early 19th century, an eager Darwin embarked on a 5-year voyage around the world aboard the HMS Beagle. This journey was not just about charting the globe's waters, it was a voyage of discovery that would revolutionize our understanding of the natural world. In the course of their travels, they stopped at the Galapagos Islands, a remote archipelago in the Pacific Ocean. This proved to be a turning point in Darwin's life. Here, he observed something intriguing: a group of finches, each species unique in its own way. What struck him was the diversity of their beaks, each adapted to suit a different diet and lifestyle. For instance, some finches had sturdy large beaks for cracking open hard seeds, while others had slender pointed beaks for catching insects. This variation was a stark contrast to what Darwin had observed on the mainland, where each species of finch had a similar beak structure. These observations planted a seed in Darwin's mind. He began to question the conventional wisdom of his time, which held that species were unchanging, created as they are by divine design. Instead, he hypothesized that species could change over time, adapting to their environment. He wondered if these finch species had descended from a common ancestor, each diverging and adapting over generations to fill different ecological niches on the islands. This was the beginning of a grand idea that would take root in his mind, an idea that would eventually become the theory of evolution by natural selection. Darwin's voyage was a journey of discovery, not just of new lands and species, but of new ideas that challenged the existing beliefs of his time. It's fascinating to think that a group of small birds on a remote island could spark such a revolutionary idea. But that's the beauty of science. It's a journey of discovery, driven by curiosity and observation, challenging our understanding of the world around us. This journey would forever change our understanding of life. In 1859, Darwin presented a theory that shook the world. With his groundbreaking work, On the Origin of Species, Charles Darwin brought forth a revolutionary concept that sent tremors through the scientific community and beyond. He proposed that all species have descended over time from common ancestors, a process he termed descent with modification. The book, a culmination of Darwin's meticulous observations and years of study, was an instant sensation. It sold out on the first day of publication, sparking heated debates among scientists, theologians, and the general public, who were captivated by its audacious ideas. Yet what was it about Darwin's theory that was so groundbreaking? At the heart of it was the concept of natural selection, often described as the survival of the fittest. Darwin proposed that individuals in a species show wide-ranging variations, and these differences affect their ability to survive and reproduce. Those with advantageous traits have a higher chance of surviving and passing on their traits to their offspring. Over generations, these beneficial traits become more common in the population, leading to evolution. This idea was a radical departure from the prevailing view that species were immutable creations. Darwin's theory suggested a continuous, dynamic process of change and adaptation, a transformative concept that challenged the static view of the natural world. But Darwin's theory did more than just explain how species evolve. It provided a unifying framework that connected diverse fields of biology. It helped make sense of the fossil record, the geographical distribution of species, and the intricate structures of living organisms. It offered a coherent explanation for the breathtaking diversity of life and its intricate interconnections. Darwin had set the foundation for modern biology. With his theory of natural selection, he provided a robust, evidence-based explanation for the evolution of life on Earth, a theory that continues to be refined and expanded upon, but remains at the core of our understanding of the natural world. Yet, like any groundbreaking theory, Darwin's theory of evolution was not accepted without a fight. Its most significant opposition came from proponents of creationism, a view that advocates for a literal interpretation of the biblical account of creation. This struggle came to a head in a landmark legal case known as Kitzmiller v. Dover in 2005. The case dealt with the teaching of creationist ideas, such as intelligent design, in public school science classrooms. The court ruled that teaching intelligent design was, in fact, unconstitutional, marking a significant victory for Darwin's theory. However, the opposition did not end there. Creationists adapted their strategies, arguing for academic freedom and the critical analysis of scientific theories like evolution. This ongoing debate underscores the broader struggle between scientific evidence and personal belief systems. At the same time, Darwin's theory faced challenges from within the scientific community itself, particularly in the early 20th century. The rediscovery of Gregor Mendel's work on genetics added a new layer of complexity to the understanding of evolution. Mendel's findings demonstrated that traits could be inherited in specific ways, which seemed to contradict Darwin's gradualist view of evolution. This led to a period of intense debate and re-evaluation of Darwin's theory. Additionally, the emergence of mutationists, who emphasized the role of sudden, large-scale changes in evolution, further challenged traditional evolutionary theory. This led to a period of uncertainty and controversy in the field of biology. Despite these challenges, Darwin's theory of evolution has not only survived but evolved. It has integrated new discoveries and ideas, demonstrating its robustness and adaptability. Despite the controversies, Darwin's theory persisted and evolved. Evolution itself has evolved over time. Quite a paradox, isn't it? Yet it's an accurate reflection of the scientific journey. The theory of evolution proposed by Charles Darwin has faced challenges and criticisms, leading to its own evolution. One such challenge came from a new framework proposed by a group of scientists called the Extended Evolutionary Synthesis, or EES. The EES argues that mainstream evolutionary theory is incomplete and fails to explain the origins of complex organs like eyes and wings. This is not a rejection of Darwin's theory, but an extension, an attempt to accommodate new discoveries and deepen our understanding of evolution. However, the EES faced backlash from traditional evolutionary theorists who accused them of seeking attention and advancing their careers. This conflict is not just about science, it's about who gets to shape the grand narrative of biology. Another significant challenge came in the form of mutationism. Mutationism posited that new species are created by large mutations, a view that contradicted Darwin's gradualism. Although initially seen as a threat to traditional evolutionary theory, mutationism was eventually incorporated into the modern understanding of evolution. It served to enrich Darwin's theory, not replace it. The decline of Darwin's theory in the early 20th century led to the rediscovery of Gregor Mendel's work on genetics. This complicated Darwin's ideas and set the stage for the incorporation of genetics into the theory of evolution, resulting in the neo-Darwinian synthesis. This synthesis effectively merged Darwin's natural selection and Mendel's genetic inheritance, creating a more comprehensive theory of evolution. So we see that the theory of evolution has not remained static. It has accommodated new scientific discoveries, incorporated criticisms, and evolved over time. Darwin's theory has been extended, challenged, and reshaped, reflecting the very essence of the scientific process. The theory of evolution, like life itself, adapts and evolves. Why does Darwinian evolution matter to us today? Well, Darwin's theory of evolution, underpinned by the principle of natural selection, is the bedrock on which we comprehend the vast biodiversity of our planet. It explains how myriad species have adapted and evolved to survive in every corner of our globe. This understanding extends beyond just animals and plants. It's crucial in comprehending disease resistance, as pathogens evolve to survive against our medical interventions. This is the driving force behind the medical arms race against superbugs and the ongoing evolution of viruses, making the knowledge of Darwinian evolution a vital tool in the arsenal of modern medicine. Furthermore, it helps us understand the potential impacts of climate change on species and ecosystems. Species are forced to adapt or face extinction, a sobering reality that underscores the urgency of our environmental efforts. Beyond biology, Darwinian principles have influenced fields as diverse as psychology, sociology, and even computer science. For instance, evolutionary psychology applies the principles of natural selection to explain human behavior and social structures, while in computer science, genetic algorithms use the concept of evolution to optimize problem solving. Darwinian evolution continues to shape our understanding of life, proving that we are all part of a grand interconnected web of existence.